balance the following chemical reactions, and classify them as either combination or synthesis. Decomposition, single replacement, or double replacement. So let's balance them first. In the first reaction, we have one silver on the reactant side and one silver on the product side. So the silvers are balanced. We have one nitrogen on the reactant side, but we have two nitrogens on the product side. So if we put a coefficient of 2 in front of the silver nitrate, we will have the nitrogens now balanced. Now, we had just finished balancing the silvers, and putting a 2 in front of the silver nitrate does mess up our balancing of the silvers. If we put a 2 in front of the silver chloride on the other side, we now will fix the silver, so we have 2 on each side, but we also now make it so that we have 2 chlorines on the product side, as we would have 2 chlorines on the reactant side. So our chlorines are balanced, 1 calcium, and last but not least, we look at our oxygens. We have 2 times 3, we have 6 oxygens, and we have 6 oxygens on the other side. This would be balanced. Now, in a reaction like this, where we have 2 compounds react to form 2 different compounds, this is a double replacement. Part B, we have iron and oxygen forming rust, iron 3 oxide. So if we look at our iron, if we put a 2 in front of the iron on this side, that'll match the 2 irons we have on the product side. If we look at our oxygens, on the reactant side we have 2, on the product side we have 3. If we go for the least common multiple, the smallest number that both of those will factor into, that would be 6. And to get 6 oxygens, we would put a 3 in front of the O2 and a 2 in front of the Fe2O3. Now, that did mess up my iron, so we now had 4 iron on the product side, so I changed my 2 to a 4 on the reactant side. We're now balanced. Now this reaction has 2 simple compounds, or even pure elements, such as this case, react to form a more complex compound. This is our combination reaction. In the next formula, part C, we have manganese 3 hypochlorite reacting with calcium metal to form calcium hypochlorite and pure manganese. Well, if we look at the manganese, we have 1 of those on each side. And again, it doesn't necessarily mean that we have to start with the manganese. Generally, we want to save the hydrogen and oxygen to the end, though. So, manganese is balanced. I have 3 chlorines on the reactant side. I only have 2 chlorines on the other side. Again, like we did with the oxygens in part B, we want to go for the least common multiple, which would be 6 chlorines on both sides. Well, that did several things. It messed up my manganese, so I need to go through and make sure my manganese rebalances. And my calciums that were balanced initially, well, they're out of balance, so I need to fix those as well. We check, as a final step, our oxygens. We have 6, 2 times 3. oxygens on the reactant side, and we have 6 oxygens on the product side. We're balanced. In this particular problem, we have a compound plus element react to form a different compound and element. This is our single replacement reaction. And finally, part D, we have calcium, one calcium on each side. They're balanced. We have 1 carbon on each side. It's balanced. We have 3 oxygens and a total of 3 oxygens. Our oxygens are balanced. This is completely balanced. And here we have a single compound breaks down into 2 or more simpler compounds or elements, and this is a decomposition. Now in this particular problem, notice where I didn't need to put anything in front of them, I left them blank. You can also go through, if you like, and place 1s in those blanks. Sometimes students like to see numbers there, so as they go back through problems on a test, they can look at it and go, oh, did I work that one or did I not work that one? Well, if you have 1s in there, as you look back through, you'll know, yes, in fact, I actually did work that one. I can move on to the next.